In the unforgiving realm of aerospace, engineering gravity is the ultimate auditor. It does not care about your budget, it does not care about your deadlines, and it certainly does not care about your assumptions. Every single weld, every titanium bolt, and every single line of computer code must be mathematically perfect, because in the vacuum of space or the violent turbulence of the atmosphere, there is absolutely no margin for error. But on the morning of June 4th, 1996, the European Space Agency learned the most expensive software lesson in human history, a lesson that proved that sometimes the most dangerous component of a $7 billion machine is a simple recycled text file. Welcome to another episode of History Glitch, where we examine the catastrophic failures of human engineering and the moments when our operating systems literally crash and burn. Today, we are looking at the infamous maiden flight of the Ariane 5 rocket, designated as Flight 501. Based on the chilling technical accounts in the book Fatal Defect Chasing Killer Computer Bugs by Ivars Peterson, we are going to explore how a tiny, mundane piece of copied and pasted code completely annihilated $500 million in exactly 37 seconds. To truly understand the sheer magnitude of this glitch, you must first understand the breathtaking scale of the Ariane 5 project. It was the absolute pride of the European space program, taking a full 10 years and a staggering $7 billion to research and develop. It was specifically designed to be the heavy-lift workhorse of the new millennium, built to carry massive commercial payloads into orbit. Sitting on top of this giant, sophisticated rocket on that fateful morning were 4 cluster satellites specifically designed to study the magnetic field of the Earth. The payload alone was valued at over $500 million. When the countdown finally reached 0, the massive solid rocket boosters ignited with earth-shattering force, and the Ariane 5 majestically lifted off the launch pad in Kourou, French Guiana. For the first 36 seconds, the flight looked absolutely flawless. The telemetric data was nominal, and the rocket was aggressively tearing through the lower atmosphere. But deep inside the rocket's dark avionics bay, a silent digital countdown to total destruction had already begun, long before the rocket even cleared the launch tower. The rocket relied on an incredibly sophisticated piece of hardware called the Inertial Reference System, or SRI, to tell the main flight computer exactly where the rocket was, its altitude, its pitch, its roll, and most importantly, its horizontal and vertical velocity. To ensure maximum safety and redundancy, the rocket was equipped with 2 completely identical SRI units, an active one and a passive backup. Inside these units, a specific piece of software was continuously running a calculation called the alignment function. This specific software module was not actually new. It had been copied directly from the older, smaller, and less powerful Ariane 4 rocket. The engineers assumed that because this exact code had worked flawlessly on dozens of Ariane 4 flights for many years, it would logically work perfectly on the Ariane 5. That single assumption was the fatal glitch that doomed the entire mission. The Ariane 5 was a completely different beast. It was much larger, it had vastly more powerful engines, and its aerodynamic flight path was significantly steeper. Its horizontal acceleration was roughly 5 times greater than its predecessor. The recycled code was designed to align the internal laser ring gyroscopes before launch, but for a very specific and outdated reason, it was programmed to keep running for exactly 40 seconds after liftoff. At exactly 36.7 seconds into the flight, the rocket's horizontal velocity value increased so rapidly that it became mathematically too large for the software to handle. The computer program attempted to take a massive 64-bit floating point number representing the rocket's extreme velocity and convert it fitted into a tiny 16-bit signed integer space. In the world of computer science, this fatal mathematical error is known as an integer overflow or an operand error. Imagine trying to pour a massive swimming pool full of water into a tiny coffee cup in a fraction of a second. The number was simply too big to fit into the memory space that had been allocated for it by the programmers. Now, in the Ada programming language which the system was written in, there are ways to handle these exceptions to tell the computer what to do if a number gets too big. But to save processing power, the programmers had deliberately disabled the protection for this specific variable because according to the flight data of the older Ariane 4, it was physically impossible for the rocket to ever reach a speed that would generate a number that large. But they were not flying an Ariane 4 anymore. When the overflow occurred, the software completely crashed, generating a diagnostic error code. The backup SRI unit, which was running the exact same recycled code and experiencing the exact same physics, had already crashed exactly 72 milliseconds earlier for the exact same reason. Both of the rocket's multi-million-dollar navigation systems were now completely deadlocked in a software fatal error. But the glitch did not stop there. It mutated into something much worse. When the active SRI crashed, it automatically transmitted its final diagnostic error data down the wire to the rocket's main flight computer. But the main computer was not programmed to recognize this specific string of numbers as an error message. It read the diagnostic bit pattern as actual physical flight data. It interpreted the error code to mean that the massive rocket had suddenly veered violently and dangerously off course. Acting instantly on this false phantom information, the main flight computer commanded the massive engine nozzles of the solid rocket boosters to instantly swing to their extreme physical limits to correct the imaginary deviation. The rocket, traveling at supersonic speed, abruptly lurched sideways. The immense, terrifying aerodynamic forces instantly ripped the solid rocket boosters right off the main core of the ship. The structural integrity of the rocket failed immediately, and it began to violently tear itself apart in the sky. Detecting the catastrophic structural failure, the rocket's automated flight termination system, its self-destruct mechanism, immediately triggered. Exactly 37 seconds after liftoff, the pride of the European space program and its $500 million scientific payload were vaporized in a massive, spectacular fireball, raining burning toxic debris down over the mangrove swamps of French Guiana. The aftermath of the Ariane 5 disaster sent absolute shockwaves through the global software engineering community. The Board of Inquiry discovered that the code that destroyed the rocket was not even needed. After liftoff, it served absolutely no purpose during the flight. It proved that in complex systems, you can never simply copy and paste code from one environment to another without rigorously testing it under the new physical parameters. Software is not just math. It is a physical component of the machine it operates. The Ariane 5 explosion is the ultimate history glitch, a stark, terrifying reminder that in our hyper-advanced modern world, a single overflowing integer, a tiny mathematical oversight, can bring a $7 billion mountain of cutting-edge engineering crashing violently back down to Earth in the blink of an eye.